Hello guys, welcome back to my YouTube channel. My name is Ishe, and today I'm going to introduce you to my new video series for deep learning, if introduction to deep learning. So you've probably heard about self-driving cars, right? You have probably seen YouTube videos where drivers, they'll be just putting their hands on their laps, and then they'll let the car take control of itself. For example, the Tesla Model 3. And you've probably seen new developments in the field of natural language processing, whereby we have home gadgets such as Alexa. You can tell Alexa what to do. You can just say, Alexa, can you please play Pop Smoke Dio, and then Alexa will translate your words into Alexa will understand your words and then will play music for you. So deep learning is inspired by how our brain works. So our brain works via a connection of various neurons, right? So in deep learning, various neurons are connected together so that they perform computations, and those computations are used to solve problems such as computer vision, natural language processing. So before we dive deeper into the details of deep learning, so today we are going to talk about the basic unit of the neural network, which is a neuron. So here we are going to just take a look of a neuron with just one input, right? So X is our input, right? And then X is our input, and then we have all the W is the weights. So the weights they give weighting to our inputs. And we also have B, which is another weight, but this B, we call B the bias, right? And then Y is the output, right? So when you compute data using the neuron, our output is Y, and then X is our input. X is our input, and then we multiply X by the connections weight, which is W. These are the weights, and then we add these weights to the bias, right? We add these weights to a bias. So let me give you a solid example. Let's say we have a problem whereby we have been hired as a deep learning engineer to predict house prices for a company, right? So let's say your input X, right? In this case, your input X is going to be the size of the bedroom. So in this case, we want to predict the price of the house using the size of the bedroom. And then, as usual, W is our weight. And then we also have B, which is the bias, right? So in this case, our input will be size of the bedroom. Our input will be the size of the bedroom, right? Which we are going to multiply by the weight, and then we are going to add the bias to it. And then in this case, we are just going to use a numerical value of 1. And then our output will be Y. And then Y is the price of the house, right? Price of the house, right? So basically, that's how a neuron works, right? The basic computation of a neural network. That's how it works, right? So in this case, let's say the size of the bedroom. Let's say the values of X are input. In this case, since in this case we'll be dealing with vectors. So let's say in this case we'll be having vectors. Let's say the size of the bedroom. Let's say we have a bedroom of 40 square meters, right? 40 square meters. And then we have another house with a bedroom, let's say, of 60 square meters, and then another one of 100 square meters, right? Something like this. So these are our values of x, and then these are our values of x, and then w are our weights, right? Let's just give them just in approximate value. Let's say 1.001, 1.002, and then 1.003, right? Something like this. And then we say that our bias is equal to 1, right? So I've showed you the diagram for the neuron, right? And then the mathematical expression of the neuron, of our neuron, is y is equals to x w plus b, which is what? The bias, right? So y is equals to, we are going to multiply these vectors, 40 m squared, 60 m squared, 100 m squared. So we are going to multiply these two vectors, right? 1.001, 1.002, and 1.003. And then we add to the bias, right? And then we add the bias to them. This will give us the price. This will give us the price of the house, right? So this is the basic mathematics of how the expression for the neural network works, right? So what about if we have a neuron with multiple inputs, right? So in this case, we are only dealing with the size of the bedroom. Only dealing with size of the bedroom. So in this, with multiple, we are going to take a look of the basic neuron, but with multiple inputs, right? In this case, x1 is going to be the size of the bedrooms. The size of the bedroom. And then let's say x2 in this case is going to be the size of the house. And then x3 is going to be, let's say, the location. So how do we represent this using our diagram for the basic neuron, right? So this will be x1. This is our basic neuron, right? This is x1, w1, which is the weight for our weights. Our weight for x1, we have x2, w2, and then we have x3, w3, and then we add the bias to it. In this case, we said the bias is going to be 1, right? So what happens is the weights determine which values are going to be given the most priorities, right? So the weights determine how the neuron works. So it's like this. As a human being, you learn by exploring the environment. Let's say you are learning how to walk. You don't just begin by running. Sometimes when you started walking, you were falling, and then from falling, your brain could calibrate your movements, and then as time went on, you could walk properly. So that's how the neuron works. So let's say we are trying to predict the prices of the house using the size of the bedroom, the size of the house, and the location. So what happens is that when we first give the neuron the data, the neuron is going to output a value, but that value is not accurate, right? And then to readjust or to relearn, the neuron adjusts its weight. It changes, the value of the weights changes, right? So I'm going to, in further videos, I'm going to explain how those values are changed, right? So the weights are calibrated so that the neural network adapts, so that as time goes on, the neural networks will start predicting the price of the houses accurately. So that's what the weights are for. The weights are used to the weights are used to calibrate how the neuron works, and they are used to also to determine which input. They are going to determine the priority of the input. They are going to, let's say, the weights are going to determine if we are going to consider x1, if x1 is going to be considered more than x2, or x2 is going to be considered more than x3 or x1. That's what the weights are for. And then the bias, the purpose of the bias, the bias doesn't have any input data associated with it, but the bias enables the neuron to modify the output independently of its input, right? So that's the purpose of the bias, right? So this was a quick explanation of how the basic neuron works. So I hope you have understood how the basic neuron works, because in the next video we are going to talk about how these basic neurons are connected so that they form what you call the deep neural networks. From the term, that's where the term deep learning came from. So thanks for watching, guys. Cheers.